NEC Section 250.66 mandates that a grounding electrode system for a service must include at least one grounding electrode conductor connected to specific elements. These elements are metal water pipes, metal gas pipes, ground rods driven into the earth, and concrete encased electrodes. The situation involves an RV pedestal with a 100 amp service. The ground bus on this pedestal is bonded to the steel pedestal body, and the pedestal is buried 24 inches in the ground. The receptacles in the pedestal are all connected to this ground bus. The query revolves around whether a ground rod or ground circuit is required to be connected to the ground bus according to the National Electrical Code. The NEC does indeed require a grounding electrode system. This system serves as a path for fault current to return to the source, helping to trip a circuit breaker or fuse and clear the fault. This is crucial for safety, as it prevents electrical shock hazards. Let's break down the relevant NEC sections. First, NEC Section 250.66 details the requirements for the grounding electrode conductor. This conductor connects the service equipment, typically the service disconnect, to the grounding electrode system. The grounding electrode system is composed of one or more grounding electrodes. These electrodes are the means by which the electrical system is connected to the earth. As mentioned earlier, acceptable grounding electrodes include metal water pipes, metal gas pipes, ground rods or pipes, and concrete encased electrodes, also known as UFA ground. The fact that the steel pedestal body is buried 24 inches in the ground introduces an important consideration. While not explicitly a concrete encased electrode, the burial of the metal pedestal does provide some degree of grounding. However, this alone is generally insufficient to meet the NEC requirements for a grounding electrode system. NEC Section 250.50 emphasizes the creation of a grounding electrode system. This section requires that all grounding electrodes that are present at a building or structure must be bonded together to form the grounding electrode system. This ensures that all available grounding paths are interconnected, providing a low impedance path for fault current. Now, let's address the specific question of whether a ground rod is required. While the buried pedestal provides some grounding, it's unlikely to meet the NEC requirements for a grounding electrode. Therefore, the addition of a ground rod is generally necessary. NEC Section 250.52 outlines the requirements for ground rods and pipes. These electrodes must be at least 8 feet long and driven into the ground. The upper end of the rod must be below the surface of the earth unless it's protected against physical damage. In areas with rocky soil, it may be difficult to drive a ground rod 8 feet into the ground. In such cases, the rod can be buried horizontally in a trench at least 30 inches deep according to NEC 250.53g. The connection of the ground rod to the ground bus is also critical. NEC Section 250.64 provides the requirements for grounding electrode conductors. This conductor must be sized appropriately based on the size of the service entrance conductors. Table 250.66 provides guidance on the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. For a 100 amp RV pedestal, the grounding electrode conductor will likely need to be at least an 8 AWG copper wire or a 6 AWG aluminum wire. The grounding electrode conductor must be connected to the ground bus in the RV pedestal and to the ground rod using approved methods. These methods include exothermic welding, listed pressure connectors, listed clamps, or other approved means. The connection must be secure and permanent. It's important to understand the difference between grounding and bonding. Grounding is the connection of the electrical system to the earth. Bonding is the connection of metallic parts of the electrical system to create a low impedance path for fault current. Both grounding and bonding are essential for electrical safety. In the case of the RV pedestal, the ground bus is bonded to the steel pedestal body. This bonding ensures that the pedestal body is at the same electrical potential as the ground bus. This helps to prevent electrical shock hazards if a fault occurs. To summarize, while the buried steel pedestal provides some grounding, it's generally not sufficient to meet the NEC requirements for a grounding electrode system. Therefore, the addition of a ground rod is typically required. The ground rod must be connected to the ground bus in the RV pedestal using an appropriately sized grounding electrode conductor and approved connection methods. This grounding system provides a path for fault current to return to the source, helping to trip a circuit breaker or fuse and clear the fault. This is crucial for electrical safety. Now let's delve a bit deeper into some of the specific NEC sections and related concepts to provide a more comprehensive understanding. NEC section 250.4a uncovers grounded systems. It states that electrical systems that are grounded must be connected to earth in a manner that limits the voltage imposed by lightning, line surges, or unintentional contact with higher voltage lines, and that stabilizes the voltage to earth during normal operation. This section highlights the importance of grounding in protecting against transient overvoltages and maintaining a stable voltage reference. NEC section 250.24 addresses the grounding of service-supplied alternating current systems. This section requires that the neutral conductor of a service-supplied alternating current system be connected to a grounding electrode system. This connection is typically made at the service disconnect. The purpose of this connection is to provide a low impedance path for fault current to return to the source. In the case of an RV pedestal, the neutral conductor of the service must be connected to the ground bus, which is then connected to the grounding electrode system. NEC section 250.28 covers the requirements for main bonding jumpers. A main bonding jumper is a conductor that connects the equipment grounding conductor to the grounded conductor neutral at the service equipment. This jumper ensures that all metallic parts of the electrical system are bonded together and are at the same electrical potential. In an RV pedestal, the main bonding jumper would connect the equipment grounding conductor to the ground bus. This ensures that the pedestal body, the receptacles, and other metallic parts are all bonded together. NEC section 250.104 addresses bonding of metal water piping systems. This section requires that metal water piping systems be bonded to the grounding electrode system. This bonding is typically accomplished by connecting a bonding jumper from the water pipe to the ground bus or the grounding electrode conductor. The purpose of this bonding is to prevent electrical shock hazards if the water pipe becomes energized. While this section specifically addresses water pipes, it's a good practice to bond any metallic piping systems that are present at the RV pedestal. Now let's consider the specific application of these requirements to an RV pedestal in a campground or RV park. RV parks are typically considered to be commercial installations, and therefore, they are subject to the same NEC requirements as other commercial installations. This means that the RV pedestals in an RV park must be installed in accordance with the NEC. In addition to the grounding requirements, RV pedestals must also meet other NEC requirements such as those for overcurrent protection, wiring methods, and receptacle spacing. The overcurrent protection for an RV pedestal must be sized appropriately for the load that it is intended to serve. This typically means that the pedestal will be equipped with a circuit breaker or fuse that is sized to protect the wiring and the receptacles. The wiring methods used to install the RV pedestal must also comply with the NEC. This typically means that the wiring must be installed in conduit or other approved raceway. The receptacles on the RV pedestal must also be spaced in accordance with the NEC. This typically means that the receptacles must be located no more than 25 feet apart. It's important to note that the NEC is a minimum standard. Local jurisdictions may have additional requirements that are more stringent than the NEC. Therefore, it's always a good idea to check with the local authorities to determine the specific requirements for RV pedestal installations in your area. In addition to the NEC requirements, there are also industry best practices for RV pedestal installations. These best practices are not required by law, but they can help to ensure that the RV pedestal is safe and reliable. One best practice is to use a high-quality RV pedestal that is designed for outdoor use. These pedestals are typically made of durable materials that can withstand the elements. Another best practice is to install the RV pedestal on a concrete pad. This pad provides a stable base for the pedestal and helps to prevent it from sinking into the ground. Another best practice is to use weatherproof receptacles on the RV pedestal. These receptacles are designed to protect against moisture and corrosion. In conclusion, the grounding of RV pedestals is a critical aspect of electrical safety. The NEC provides specific requirements for grounding electrode systems, grounding electrode conductors, and bonding. By following these requirements and industry best practices, you can help to ensure that RV pedestals are safe and reliable. Remember to always consult with a qualified electrician to ensure that your RV pedestal installation complies with all applicable codes and regulations. Safety is paramount, and proper grounding is a key element in ensuring the safety of RV electrical systems. Let's consider some potential scenarios and how the grounding system would function in each case. Firstly, imagine a situation where the hot wire inside an RV pedestal comes loose and contacts the metal enclosure of the pedestal. Without proper grounding, the entire metal enclosure would become energized at 120 volts. Anyone touching the enclosure would be at risk of electric shock. However, with a properly installed grounding system, the fault current would flow through the metal enclosure, through the grounding electrode conductor, and into the earth. This high fault current would quickly trip the circuit breaker or blow the fuse, energizing the circuit and eliminating the shock hazard. Secondly, consider a situation where lightning strikes near the RV pedestal. Lightning strikes can induce high voltage surges in electrical systems. Without proper grounding, these surges could damage equipment or cause fires. However, with a properly installed grounding system, the surge current would be diverted to the earth, protecting the electrical system from damage. The grounding electrode system provides a low impedance path for the surge current to flow to ground, minimizing the voltage rise in the electrical system. Thirdly, imagine a scenario where there is a gradual degradation of the insulation on a wire inside the RV pedestal. Over time, this degradation could lead to a small leakage current flowing from the wire to the metal enclosure. This leakage current might not be large enough to trip the circuit breaker, but it could still create a shock hazard. With a properly installed grounding system, the leakage current would flow through the metal enclosure, through the grounding electrode conductor, and into the earth. This would keep the metal enclosure at or near ground potential, minimizing the risk of electric shock. The grounding system also helps to reduce electrical noise and interference. Electrical noise can be generated by various sources, such as motors, appliances, and electronic equipment. This noise can interfere with the operation of sensitive electronic devices. A properly installed grounding system can help to reduce this noise by providing a low impedance path for the noise current to flow to ground. This reduces the voltage fluctuations caused by the noise current, improving the performance of electronic equipment. It's also important to consider the inspection and maintenance of the grounding system. The grounding system should be inspected periodically to ensure that it is in good condition and that all connections are tight and corrosion-free. The grounding electrode conductor should be checked for damage or corrosion. The ground rod should be inspected to ensure that it is still driven properly into the ground and that it is not corroded. If any problems are found, they should be corrected immediately. Proper maintenance of the grounding system is essential for ensuring its continued effectiveness in protecting against electrical shock hazards and equipment damage. Let's consider the specific requirements for sizing the grounding electrode conductor. As mentioned earlier, NEC Section 250.66 provides guidance on the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. The service entrance conductors are the conductors that bring power from the utility to the RV pedestal. The size of the service entrance conductors is determined by the ampacity of the RV pedestal. For a 100 amp RV pedestal, the service entrance conductors would typically be 4 AWG copper or 2 AWG aluminum. According to Table 250.66, for 4 AWG copper service entrance conductors, the minimum size of the grounding electrode conductor is 8 AWG copper or 6 AWG aluminum. It's important to note that these are minimum sizes. It may be necessary to use a larger grounding electrode conductor in some cases, such as when the soil resistivity is high or when there are multiple grounding electrodes. The local electrical inspector can provide guidance on the appropriate size of the grounding electrode conductor for a specific installation. In addition to the size of the grounding electrode conductor, It's also important to consider the type of conductor. The grounding electrode conductor can be either copper or aluminum. Copper is generally preferred because it has a lower resistance than aluminum. However, aluminum is less expensive than copper. If aluminum is used, it must be properly installed to prevent corrosion. Aluminum conductors should be installed with antioxidant compound to prevent oxidation and ensure a good electrical connection. The grounding electrode conductor must be continuous from the ground bus in the RV pedestal to the grounding electrode. Splices are not permitted in the grounding electrode conductor. This ensures that there is a lower impedance path for fault current to flow to ground. The grounding electrode conductor must be protected from physical damage. This can be accomplished by installing the conductor in conduit or by routing it in a protected location. The grounding electrode conductor must be securely connected to the ground bus in the RV pedestal and to the grounding electrode. The connections must be made using approved methods such as exothermic welding, listed pressure connectors, or listed clamps. The connections must be tight and corrosion-free. It's also important to consider the location of the grounding electrode. The grounding electrode should be located as close as possible to the RV pedestal. This minimizes the length of the grounding electrode conductor and reduces the impedance of the grounding path. The grounding electrode should be located in an area where the soil is moist and conductive. This ensures that the grounding electrode is effective in dissipating fault current. The grounding electrode should be located away from underground utilities, such as gas lines and water lines. This prevents damage to the utilities and reduces the risk of electrical shock. Remember to consult with a qualified electrician and follow all applicable codes and regulations when installing an RV pedestal grounding system. This will ensure that the system is safe and effective in protecting against electrical shock hazards and equipment damage. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice.